Hello, welcome to Blockish Dev. I'm Aisha. In this video, we're going to cover the basic concepts, models, and terminologies that are essential for you to build the right mental model on how smart contracts work on Cudos, another Cosmos-based blockchain. Welcome to Blockish Dev, a channel where I discuss decentralized technologies and blockchain development. I'm Aishat Akinyemi. Cudos is a blockchain powering CudosCompute, a decentralized cloud computing network that enables people and companies to trade their spare computing resources. And Cudos is built with Cosmos SDK and uses CosmWasm, the smart contracting platform of Cosmos-based blockchain. Cudos is a Cosmos-based blockchain. Therefore, like other Cosmos-based blockchain, it uses CosmWasm, which is the smart contracting platform that allows you to build multi-chain smart contracts, because the same smart contract that works on Cudos would work on any other Cosmos-based blockchain that uses CosmWasm. So you can think of CosmWasm as Cosmos and WebAssembly. CosmWasm runs smart contracts written in Rust that's compiled to WebAssembly. Theoretically, any language that compiles to WebAssembly can be used to write CosmWasm smart contracts, that is Cudos smart contracts. But for now, Rust is the language that is currently supported. Rust is a highly performant programming language that enables building of reliable and efficient software. It has a great documentation, and on this channel, there's going to be a learn along series on Rust. So watch out for that. Smart contracts are autonomous executable logic deployed on a blockchain. And the smart contract usually has an internal state where you can read and write data on. So the data layer of the data part of the smart contract is the storage, which maintains the state of a smart contract. Executing smart contract code on a blockchain takes computation resources of nodes. So validator nodes are incentivized to execute contracts through gas fees. And the amount of gas a contract takes is equivalent to the amount of computational resources the contract takes to execute. Each smart contract can be thought of as an actor, and an example of an action would be a smart contract that makes cake. An example of an action would be making a request to buy a cake. Actors respond to messages they support, and the state of a smart contract usually changes as a response to a message it receives. An actor in a system may affect other actors through messages. So actors interact with each other via messages. Smart contracts interact with each other via messages. Another characteristic of the actor model is that the smart contracts process messages in a first in, first out manner, and transactions are handled as they come in. So a smart contract maintains an internal queue of the messages it executes. An action can be thought of as a complete thing performed by the smart contract, and this includes messages that the smart contract has to submit to other contracts before it finishes the action. So in the case of making an order for a cake, the smart contract might be the one handling payments, and then it schedules some messages to other smart contracts, which might include making the dough, baking the cake, decorating the cake. So in that case, when all these actions have completed, that is when we would say the message has been executed successfully. And if any of this action fails, then the transaction reverts and it fails. Yeah. A smart contract interacts with other smart contracts through a dispatcher, and the dispatcher maintains the state of the system and maps addresses to code. So there's loose coupling between smart contracts and the serialized execution, the first in, first out approach that we talked about, prevents reentrancy by design. And reentrancy attacks are one of the most common attacks in Ethereum-based blockchains that run with Solidity. And I'm going to explain what are reentrancy attacks. The idea is that in the middle of handling a message in contract A, the contract that handles where we make a request for a cake, the contract calls a second contract B and transfers control to it. Contract B can then make another call to contract A again. And in this case, there are two different copies of contract A running. So for a transaction that involves sending tokens, there may be local changes in memory in contract A from the first call, which are not yet persisted, and the second call uses the outdated state a second time. So the transaction or the transferring of tokens can be authorized twice. And this has been previously exploited in the DAO hack on Ethereum. Smart contract actions. We have state-modifying actions which change the state of the smart contract, and we have query actions which read data from the state of the smart contract. And the development process or interacting with a smart contract on Cudos involves 3 different stages. You program, compile, and deploy the smart contract on Cudos. The next is you instantiating the smart contract with initial data. Unlike Ethereum smart contracts, you have to instantiate a smart contract on Cudos. And thirdly, after instantiating this contract, we can now execute the contract code by sending messages to the contract. The contract code base has some different files, and some of the important files are the state.rs file, contains the definition of the smart contract's data storage. The message file contains the structs that define types of messages the smart contract caters for. And the contract.rs file usually contains the entry points, which are the functions that handle the messages in a smart contract. So this is what the state.rs file looks like, and each data item or the smart contract has a unique key with which we can view or read the data from, the data that is tied with that key. And the message.rs file, this is what it looks like. You can have different messages defined in the message.rs file. So going to the contract.rs files, as we said, it's the file that contains the entry points, the functions that handle the different messages supported by smart contract. So we have the instantiate entry points. What this does is, you can see from the name, it handles the instantiation of the smart contract. The execute entry point handles the state mutating actions. So like mutating actions that change the state of the smart contract are handled by the execute entry point. And the third entry point is the query entry point, through which we read data from the smart contract. So this is what the instantiate entry point looks like. The result it returns is either success message, which would be a response, or a contract error. So the execute entry point, it takes several things, including the message, and it returns a response that could contain an event or an error. And thirdly, the query entry point takes the same thing and returns the standard result. Cudos Blast. So Cudos Blast is a very important tooling for developing and deploying Cudos smart contracts. It is a CLI tool for interacting with the Cudos blockchain, and you can use it to scaffold, compile, and test and deploy your smart contracts on the Cudos blockchain. The next video I'm going to upload is going to be us setting up the development environment to start developing smart contracts on Cudos. And also we're going to install Cudos Blast, and we're going to deploy our first smart contracts. Do watch out for that, and make sure you subscribe to my channel for more videos like this. Thanks for watching. See you next time. Bye.